Hello friends, welcome back to my YouTube channel. Today I will continue my discussion on high pressure vessels, and the plan for today is to discuss a numerical based on the four theories of elastic failure that I have discussed in my previous videos. So at the end of this discussion you will learn how to get the thickness for a high pressure vessels by using the four theories of elastic failure. I am giving links to those videos where I have discussed the theories of elastic failure, and today we will apply those theories to find out thickness of a high pressure vessel. Now let us look at the numerical statement. So you have a cylindrical vessel with an internal diameter of 250 mm is to be designed to withstand an internal pressure of 120 meganewton per meter square. Mild steel having a yield stress of 450 meganewton per meter square is to be used. The Poisson's ratio is 0.3 and a factor of safety of 1.5 is to be used. Calculate the wall thickness of the vessel using the following theories of elastic failure: maximum principal stress theory, maximum shear stress theory, maximum strain theory, and then maximum strain energy theory. So for the given conditions, we are supposed to calculate the thickness of this cylindrical vessel by using each of the theory that is listed over here: maximum principal stress theory, maximum shear stress theory, maximum strain theory, maximum strain energy theory. As I said earlier, I have discussed all these four theories in my previous videos. I am giving links to those videos in the description section. You please watch those videos. So first let us collect the information that is given to us. I am calling it as given data. So you have a cylindrical vessel. A cylindrical vessel is given to us. Then the internal diameter of the cylindrical vessel is given to us. I am denoting it as di. So di is 250 mm. That is 250 into, if I convert it to meter, it will be 250 into 10 to the power minus 3 meter. Then the internal pressure is given. Internal pressure, we denote it by Pi. So that is given to be 120 meganewton per meter square. The yield stress for the material of construction is mild steel, and for mild steel, the yield stress is given to us. That is, as per our notation, sigma y is given to us. Sigma y is 450 meganewton per meter square. The Poisson's ratio is also given. Poisson's ratio, that is mu, it is 0.3. The factor of safety to be used, that is given to us, that is Fs is 1.5. I denote the factor of safety by Fs. So Fs is 1.5. And what are we supposed to calculate? We are supposed to calculate thickness of this vessel by using maximum principal stress theory, maximum shear stress theory, maximum strain theory, and then maximum strain energy theory. So each of these theories will give us a different thickness. And now let us check how much is the difference in the thickness calculated by using these four theories. So let us solve it. First, we will do calculations for maximum principal stress theory, and for that I am going to use the equation, or the first step is to find K, and for that I'll be using equation for K. So I have derived this equation in my discussion on maximum principal stress theory. Link is in the description section. You please watch it. So over here I am directly using that equation. So K according to maximum principal stress theory. And what is K? K is the ratio of outer diameter to inner diameter. So K is equal to du upon di. So according to maximum principal stress theory, K is given as sigma y plus pi into Fs divided by sigma y into pi into Fs, sigma y minus pi into Fs raised to 1 by 2. K is equal to sigma y plus pi into Fs divided by sigma y minus pi into Fs. What things are known to us? Sigma y is given to us, it is 450 meganewton per meter square. Internal pressure is given, it is 120 meganewton per meter square. Here you have an option of using design pressure. While designing vessels, instead of using the operating pressure, we can use design pressure, and design pressure will be say 5% more than the operating pressure. So in this case, if I say PD is the design pressure, PD will be equal to 1.05 times of PI. So you can do that. This can also be done. But over here I will show calculations by using PI itself, the given internal pressure, which is 120 meganewton per meter square. Then factor of safety is given to us. Factor of safety is 1.5. So if I just have to put the values to get K. So K will be 450 plus 120 into 1.5 divided by 450 minus 120 into 1.5 raised to 1 by 2. And if I solve it, I'm going to get K as 1.53. So if you solve this, K that will be obtained, or K that is obtained is 1.53. So that ends our first step. The objective of the first step was to get K, and now we have got the value of K. So K, according to maximum principal theory, maximum principal stress theory, it comes out to be 1.53. Now the next step is finding du, and for that we are going to use definition of K. So K is ratio of outer diameter to inner diameter. Inner diameter is given to us 250 mm. Let us use it in mm, so that we will get du in mm as well. So that will be K is 1.53 that we have obtained over here. So 1.53 is equal to du upon 250. That gives us du as 1.53 into 250. That is, du comes out to be 381.88 mm. The outer diameter. Okay, so outer diameter according to maximum principal stress theory is 381.88 mm. Now let us find out the thickness. The third step is to find thickness. So for that I will show you the schematic of the vessel from the top. So you have the outer diameter du, then the inner diameter di, and this is the thickness. This is also thickness. So if you try to get relationship between du and di, du will be equal to ts plus di plus ts, that is di plus 2 times of ts. So we can get equation for ts. So that will be du minus di is equal to 2 into ts. That is, ts is equal to du minus di upon 2. So du is, we calculated it in the previous step, it is 381.88 mm. Then di is given to us, it is 250 mm. Therefore, ts will be 381.88 minus 250 divided by 2 after putting the values of du and di. So that gives us ts as 65.94 mm, and I can approximate it to 66 mm. So based on the new value for ts, I can calculate the updated du. Again, I will use this equation. Du is equal to di plus 2s. That is, du is equal to 250 plus 2 into 66, and that gives us DO as 382 mm. Okay. So according to maximum principal stress theory, the outer diameter of the vessel is 382 mm and thickness is 66 mm. So this is how you are supposed to use equation for K that was obtained for the maximum principal stress theory. Next, let us use the next theory, which is maximum shear stress theory. So first step is to find K, and for that we are going to use equation for K according to maximum shear stress theory. Again, I have derived the equation in my earlier videos. Link is available in the description section. So as per this theory, K is given as sigma y upon sigma y minus root 3 into pi into Fs and square root of the entire term. So sigma y is given to us 450 meganewton per meter square. Pi is given to us 120 meganewton per meter square. Again, you can use design pressure, which would be at least 5% more than the internal pressure. But over here, I am using the internal pressure. Then factor of safety is given, Fs is 1.5. So with these values, K will be equal to 450 divided by 450 minus root 3 into 120 into 1.5. I am putting all the values and square root of the entire term. So after I solve this, I am going to get value of K as 1.80. So according to maximum shear stress theory, K is 1.80. Okay, that ends first step. Second step is to find DO, and for that we are going to use the defining equation for K. K is DO upon DI. DI is 250 mm. K we just got, it is 1.8. So 1.8 is equal to DO upon 250. That gives us DO as 1.8 into 250. That gives us DO as 450 mm, the outer diameter. Now, once you get the outer diameter, let us calculate the thickness. Finding the thickness. So for that, again, we will use this schematic, which will help us to know what is the relationship between DO and DI. The relationship is DO is equal to DI plus 2S. You can easily understand. So that is DO minus DI is 2TS. That is TS is equal to DO minus DI upon 2. DO is 450 mm. According to maximum shear stress theory, DI is given to us, it is 250 mm. Now let us use the values. Therefore, TS will be 450 minus 250 upon 2, and that gives us TS as 100 mm. So according to maximum shear stress theory, the thickness of this particular high pressure vessel comes out to be 100 mm. Okay. Now let us use the third theory, maximum strain theory. Again, the first step is finding K, and we will be using equation for K as per the maximum strain theory. So in this case, the equation for K is sigma y plus pi into 1 minus mu into Fs divided by sigma y minus pi into 1 plus mu into Fs, square root of the entire term. So again, I have derived this equation in my discussion on maximum strain theory. Link is available. You can check. So sigma y is 450 meganewton per meter square, pi is 120 meganewton per meter square, Fs is 1.5, mu is 0.3. Let us use the values. So K will be 450 plus 120 into 1 minus 0.3 into 1.5 divided by 450 minus 120 into 1 minus 0.3 into 1.5 raised to 1 by 2. This is 1 plus 0.3 into 1.5 square root of the entire term. So if you solve it, K will come out to be 1.63. So once you get K, next step is finding DO. So K is DO upon DI. DI is 250 mm. K you got 1.63. So it will be 1.63 is equal to DO upon 250. That is DO is equal to 1.63 into 250. That gives us DO as 407.5. Next is, let us find the thickness. Again, we will use the schematic diagram. The relationship is DO is equal to DI plus 2S. 2 Ts, that is dO minus di is equal to 2 into Ts, that is Ts is equal to dO minus di upon 2. dO is 407.5, which we got. di is 250 mm. So if you use these values, Ts will be 407.5 minus 250 upon 2. That gives us Ts as 78.75 mm. And if I approximate it to be 80 mm, I will have to calculate the updated diameter. So updated diameter will be dO is equal to di plus 2 Ts. Therefore, dO is equal to 250 plus 2 into 80. That gives us dO as 410 mm. So according to this theory, the thickness of the vessel is 80 mm, and with this thickness, the outer diameter for the vessel will be 410, that is 410 mm. Now, the fourth theory, which is maximum strain energy theory. Again, the first step is finding K. Regarding this theory, or in the case of this theory, final equation for K was not obtained. I'm not going to use the final equation. Instead of that, I'll be using equation for sigma y that was obtained according to this theory, maximum strain energy theory. Again, I have discussed it in my discussion on this particular theory. Link is available, you can check. So sigma y is 450, given things, 450 meganewton per meter square, pi is 120 meganewton per meter square, EFS is 1.5, mu is 0.3. So if you put all the values, this will be 450 is equal to 1.5 into 120 divided by k square minus 1. We are going to find k into under root of 2 into 1 minus 0.3 plus 2 into 1 plus 0.3, k raised to 4. So that is 450 is equal to 180. So 1.5 into 120 is 180. So 180 divided by k square minus 1 into within the square root. Under the square root, you get this simplified terms. So this is 1.4 and this is 2.6. So 450 is equal to 1.8 upon k square minus 1 into under root of 1.4 plus 2.6 into k4. K raised to 4, sorry. So this is k square minus 1 is equal to 180 upon 450 under root of 1.4 into 1.4 plus 2.6 into k raised to 4. So what is done? 450 is brought on the side and k square minus 1 is taken to the other side. So that is k square minus 1 is equal to 0.4 into under root of 1.4 plus 2.6 into k4. So 180 divided by 450 is 0.4. So in the next step, I'll square on both the sides. So this will be k square minus 1, square of that is equal to square of 0.4 is 0.16. So 0.16 and square root of a square root, square of square root, the square root will go and you are left with 1.4 plus 2.6 into k raised to 4. That is, if this bracket is solved, you'll get k raised to 4 minus 2k square plus 1. So for that, I'm using this expansion a minus b square. So a minus b square is a square minus 2ab plus b square. So I have used this expansion to get this equation. So that will be k raised to 4. Let me use, so k raised to 4 minus 2 into k square plus 1, that is equal to 0.16 into 1.4 is 0.224, 0.16 into 2.6 is 0.416 k raised to 4. So in the next step, little rearrangement is done. So k raised to 4, this term is brought on this side. So it will be k raised to 4 minus 0.416 k raised to 4 minus 2k square plus 1. And this term, when it is brought on the left hand side, it will be 1 minus 0.224, that is equal to 0. So that is, finally you get 0.584 k into k raised to 4 minus 2k square. So k raised to 4 minus 0.416 k raised to 4 is 0.584 k raised to 4 minus 2k square plus 1 minus 0.224 is plus 0.776, that is equal to 0. So we got this 0.484 k raised to 4 minus k square plus 0.776 is equal to 0. Now what I will do for simplification, I will use capital M for k square. So if I use that in the equation, I will get 0.584 m square, because k raised to 4 is k square square. So that will give m square minus 2m plus 0.776 is equal to 0. And in the next step, I'll divide with 0.584 throughout this equation. So this will be 0.584 divided by 0.584 is 1. Then 2 divided by 0.584 is 3.42. And 0.776 divided by 0.584 is 1 plus 1.33. So after dividing, so in this case, I am dividing the equation with 0.584. What is the purpose? The purpose is to make the coefficient of m square 1. So that now this equation is equivalent to ax square plus bx, quadratic equation, plus c is equal to 0. So in this case, a is 1, b is minus 3.42, a is 1, b is minus 3.42, and c is 1.33. Of course, in this case, the quadratic equation is in terms of m. So let me write it in the same way. So it is a into m square plus b into m plus c is equal to 0. And root of this equation will be given as m is equal to minus b plus minus under root of b square minus 4 into a into c divided by 2 into a. So I'm going to use this equation that gives me roots of a quadratic equation to get the value of m. Okay, so I hope this is clear to you. If you have any doubts, you please mention them in the comment section. Okay, now let us move ahead. So I am going to use the equation for finding square root of a quadratic equation. So that gives me m is equal to minus b. So minus, in this case, b is minus 3.4. So minus 3.42 plus minus under root of b square. B is minus 3.42. So minus 3.42 square minus 4, a is 1 and c is 1.33. So it was minus 4 into 1 into 1.33 divided by 2 into 1. So that gives me, after simplification, m will either be, that means when I use plus sign over here, I get m as 2.97, and when I use negative sign minus over here, I get m as 0.45. So that is k square, m is k square, k square is 2.97 or k square is 0.45. That is k is 1.72 or k is 0.67. But as per definition of k is ratio of outer diameter to inner diameter, and outer diameter is always greater than the inner diameter. That means k will always be greater than 1. That means out of these two values, we are going to choose that value that is greater than 1. That is k will be 1.72. Okay. So after getting k, now let us get du. So for that k, we are going to use equation for k. K is equal to du upon di. Di is 250 mm. K we just found it is 1.72. So that gives us 1.72 is equal to du upon 250. Du is equal to 1.72 into 250. That is du comes out to be 430 mm. And then you can find the thickness by using the same equation. Du is equal to di plus 2ts. You can follow this equation with the help of this diagram. So du minus di is 2ts. That is ts is equal to du minus di upon 2. And if you put all the values, du is 430, di is 250. So therefore ts will be equal to 430 minus 250 upon 2. And that gives us ts as 90 mm. So in this way, we get thickness for the vessel according to maximum strain energy theory. So that is the end of our solution. At the end, we have got thickness according to thickness by using all the four theories, and it is evident that each theory has given a different thickness. I hope you have understood the solution. You have understood the calculations. If you have any doubts, you please mention them in the comment section. With this, I am going to end my discussion for this particular video. I hope you now know how to calculate thickness by using any of the theory of elastic failure. The idea is use the equation for K, get K, and from K get outer diameter and then the thickness. So thanks for watching my video. Do subscribe to my channel, tell your friends to subscribe to it, and I hope to see you soon in my next video on another topic in chemical engineering. Thanks. Have a nice day.